Now, let us discuss plate tectonic theory and northward movement of the Indian plate. Imagine looking at the world map. Today India lies in the South Asia, but if we travel back 200 to 250 millions ago, 200 to 250 million years ago, ठीक है ago, ठीक है, India wasn't even close to Asia. It was located far south of the equator. It was attached to the Africa, Antarctica, Australia, Madagascar, and South America. So, in other words, we can simply say India was once part of a giant southern supercontinent called Gondwana land. It was part of this land. This is a big supercontinent. Okay? Over millions of years, India broke away, traveled thousands of kilometers northward across the ancient, this the Dead Sea. Okay? This is the ancient sea. Okay? And eventually, India was collided with the Eurasian plate. Okay? Now, remember this. Okay? So, that collision gave birth to Himalayas, that Tibetan plateau, and continue to produce earthquakes today. So this incredible journey is explained by the tectonic plate theory. Let's go. What is plate tectonic theory? Plate tectonic theory states that Earth's outer rigid shell, that is lithosphere, is broken into several large and small tectonic plates, and that moves slowly over the semi-molten asthenosphere due to internal forces such as mantle convection. So I'm going to write very simple definition right now. So simple, it is plate tectonic theory is the Earth's outer layer. The Earth's outer layer is not one solid piece. Okay? It is of different small tectonic plates. Okay? So it's not one solid piece. Okay? It is broken into different small tectonic plates. Remember different tectonic plates. Okay? And these move continuously. So let me tell you one example. Think of a cracked eggshell. Okay? The shell is broken into pieces. Okay? But all the pieces still fit together. They still fit together. Okay? Similarly, Earth crust is, it is divided into several plates. So, why actually this plate tectonic theory is needed? Why? Before plate tectonic theory, scientists noticed many puzzling facts. Okay? Continents look like they fit together. Example, South America and Africa. And what else? Similar fossils occur in continents now separated by oceans. And what else we have? Similar rock types are found on distant continents, Australia, India. And what else? Earthquakes and volcanoes occur in specific belt rather than randomly. Okay? So these observations led scientists to conclude that continents must have moved. Right? Continents must have moved. I'm gonna increase my pace so that I'll complete every chapter in 1 hour. Okay? I'll do that from the third chapter. Okay? So let's see the Earth's internal structure. Okay? Earth's internal structure. We're going to complete the entire third chapter in this, and from the next video, I think most possibly today only I'll try to upload third, fourth, fifth chapters in 1 hour, each 1 hour. Okay? So before understanding plate movement, we need to know the earth layers. What is Earth internal structure? How many layers are there? Okay? The first one is crust. Okay? The first one is crust. It is Earth's outermost layer. ठीक है, right, Earth's ठीक है, it is a Earth's outermost layer. I'm just looking for the map to show, but it's not available here in this room. So I'll try to draw the diagram so that you'll understand. Okay. How can I draw this? I'm just drawing this. Just treat it as a rough diagram, but just you'll just understand. Okay, by this example. So the first one is, okay, the inner core. This is inner core, and there is one more layer, that is outer core. Okay, and then this part, just remember this part. After this part is known as mantle, and remaining the part is here, right? Remaining, this is a most outermost layer. Okay, that is known as crust. Okay, mantle, inner core, outer core, then mantle, then crust. Okay, chalo. So remember, earth crust is the outermost layer, and thickness is around 5 to 70 kilometers. Okay, so continental crust is thicker and lighter, oceanic crust is thinner and denser. Just remember this. And now let us see the second one, that is, I'm just giving the overview so that you can understand. Okay, the other one is mantle. It is it's around I can recall it is around 900 kilometer depth. 2900 kilometer depth. I think this is what I've read. So yeah, okay. So it is composed of hot, dense rocks. Remember this. Mantle contains hot and dense rocks, and upper mantle contains this layer, asthenosphere. Okay, it is partially molten. Okay, then the last one is core. That's the innermost. We have outer and inner. So okay, it is extends up to from this 2900 kilometers to roughly around, I can recall it is 6 kilometer plus. Okay, it is the earth center, right? So now I have to mention some important factor, that outer core, just not today, outer core is liquid. Okay, it's in liquid stage. It contains iron and nickel. Okay, iron and nickel. We have other one, that is inner core, and this is a solid. Okay, remember, it is liquid and this one is solid, and this is due to immense pressure. Remember, immense pressure is inside of the earth, so due to that it is solid. So chalo, let's discuss about the lithosphere. Okay, let's discuss about the lithosphere. Generally, lithosphere is the rigid outer layer. Okay, it's the rigid outer layer of the earth. Okay, lithosphere generally consists crust and uppermost solid part of the mantle. Okay, and it is broken into tectonic plates. It contains crust and uppermost this part, solid part of mantle. Okay, so it is broken into tectonic plate. Okay, now the other one is, I hope it is visible, the other one is asthenosphere. Asthenosphere, now this is how I pronounce it. So this layer is weak. Okay, it is weak. Just now we discussed it's semi molten. Okay, what else? Ductile layer. Okay, ductile, ductility, I don't know how many of you remember this. It's a ductile layer beneath the lithosphere. Beneath the lithosphere. Okay, on which tectonic plates will float. Alright, tectonic plates will float. Okay, so I'm gonna give some examples so that you can understand. So imagine an ice cube floating on the thick syrup. Okay, an ice cube floating on a thick syrup. Okay, now this ice cube, this is ice cube, right? And this is syrup. This ice cube is lithosphere. Okay, and this syrup, okay, and this syrup is asthenosphere. Okay, it is semi molten, ductile and weak. Okay, so the plates float and move over this weak layer. Remember this. Now, why do plates move? Why? This is one of the most important conceptual questions, because the main reason is the mantle convection. I'll write here. Why do plates move? Why actually? Reason is mantle convection. Mantle convection. Let's see what is mantle convection. Deep inside the earth, temperature exceeds 4,000 to 6,000 degrees Celsius. Remember, it's very high. Okay, hot material becomes less dense and rises. Near the surface, it cools, becomes denser and sinks. Remember, hot material becomes less dense and rises, and near the surface, it cools and becomes denser and sink. So this continuous circulation creates convection currents. Okay, and these currents slowly drag the tectonic plates. Okay, example, when you boil milk or soup, you see the liquid continuously circulating. Okay, and the earth's mantle behaves similarly but extremely slowly. Okay, now remember this. Now for your idea, I'm not going to write the some of the major tectonic plates, but just I'll spell. So there are 7 major plates. I'll write, even though the time takes. I'll write, there are 7 major tectonic plates. Okay, the first one is Pacific plate. Okay, the first one is Pacific plate. Second one is North American plate. I write A for America, North America plate. And then we have South SA. I write South SA for South America plate. And the fourth one is Eurasian plate. Remember this, Eurasian plate. Okay, and the fifth one is African plate. And the sixth one is Antarctic. Okay, Antarctic plate. And remember this, Indo-Australian plate. Now India, Australia are in the news. Okay, we have been with several deals with Australia, and Prime Minister, he's been to Australia. So there are a lot many things I've posted in the channel, so try to watch and make note. So Indo-Australian plate, okay, it is often discussed today because Indian and Australian plates behaving somewhat independently, okay. Now what is Indian plate? Indian plate is a major tectonic plate carrying India. Plates carries India, parts of Indian Ocean, allied India, parts of India, parts of Indian Ocean, and a portion of Himalayas, okay. India plates carries this, so it moves generally towards north and northeast, and it's about 5 centimeter per year, remember. So this movement continues today also, okay. Now there are types of plate boundaries are there I have to discuss. I'll just write so that you will understand. Types of plate boundaries. The first one is divergent boundary. Just remember this. Divergent boundary, it is constructive in nature, okay. Plates move away. Divergent, okay. Plates move away from each other, remember, they move away from each other. So this is one of the type of plate boundary. So these will affect new crust formations, mid-ocean ridges develop here, volcanic activity occurs. Example is mid-Atlantic ridge. Search about this in the Google, you will find this or read about this. And there is other one, that is convergent boundary. What is this? Here plates move together, okay. Plates, they move together, and due to this, what are the outcomes? Here we have seen volcanic activity occurs, mid-ocean ridges develop here, and new crust formation are here. And now what are the possible outcomes here? Here we are able to see fold mountains, deep ocean trenches, powerful earthquakes, and volcanoes depending on plate type. So example is Indian plate, okay. Indian plate now colliding with Eurasian plate, okay. Eurasian plate, okay. Remember this. So now there is other one, that is, I'm not going to write that here, that is transform boundary. Plates slide past each other horizontally. So just remember this for your knowledge. So what is now we have done with plate tectonic theory. Now let us see the other theory, that is continental drift theory. Continental drift theory, it is very important, remember. Continental drift theory. Before plate tectonic theory, there was this Alfred Wegener's continental drift theory in 1912. I can recall this. So the main idea here is all continents were once joined into a single super continent called Pangea. So it is a single supercontinent, okay. Once all continents were joined into a single supercontinent, that is Pangea, and it's around I can recall 200 to 250 million years ago. This Pangea broke out, okay. That supercontinent broke out, okay. And here Pan means all, remember this. This Ga means earth, Pangea. So all earth, it means all earth. Now it was surrounded by a vast ocean called Panthalassa. This was surrounded by it was a vast ocean. It's a super ocean. It is called, remember, Pantalasa. Pantalasa. Pangea Pantalasa. Now, let's see. We are getting closer. Okay. Now we have seen that the supercontinent Pangea is broke. Okay. And that Pangea I'll write here breakup of supercontinent. Okay. Now it was generally it was broke into two super land masses, two large land masses. One is in north, that is Laurasia. Okay. It included North America, right? A for North America, then Europe and Asia except India. Remember, Asia except India. Now in the south, north में Laurasia, in the south there is this Gondwana land in the south, and these included India, Africa, Australia. Okay. What else we have? Antarctica. Here North America, here South SCA means South America, and Madagascar. Madagascar. So India was firmly attached to Gondwana land. So what is this? I have told about this sea, Tethys Sea. Yeah, okay. Tethys Sea. What is this? The Tethys Sea. What is this? So between Laurasia and Gondwana land, between this Laurasia, let's see, this is Laurasia and this is Gondwana land. These two are the super land masses. There is a shallow sea. Okay, there is a shallow sea called this one, Tethys Sea. So over millions of years, a river deposited thick layers of sediments into this sea. So these sediments later become the rocks, and that now form the Himalayas. Remember this. Now, yeah, we have done with the supercontinent and the broke of supercontinent, and then we have seen Laurasia in the north, Gondwana land, continental drift theory. All of these are part of continental drift theory, and we have also seen plate tectonic theory. Now, why are the Himalayas called young fold mountains? Why Himalayas called young fold or folded mountains? Why? Because remember, Himalayas are they are geologically young, okay, and they created by the folding due to continental collision. And what else? They're still rising because plate convergence continues, and they're highly prone to earthquakes and landslides and instability. Okay. So yeah, so we have done with plate tectonic theory, lithosphere, asthenosphere, mantle convection. What else? This one, Pangea, Gondwana land, Laurasia, Tethys Sea, continental collision. Okay. And convergent plate boundary. What are the different boundaries? Okay. Now let us see the geological divisions of India. Okay. Chalo, we need to complete this the entire chapter. So, geological divisions, geological divisions of India. ठीक है, geological divisions of India. So we will explain very detailed, why India is divided into three geological divisions. Okay, there are three geological divisions. Why? And those regions are the peninsular block, the Himalayas and other peninsular mountains, and the Indo-Ganga Brahmaputra plain or Indo-Gangetic plain. So from here onward, every landform in India can be understood through the geological history. So we have just built, and this creates a complete conceptual bridge between Earth's evolution and India's present day physiography. Chalo. Now, let me ask you some questions. Okay. So, I thought to bring the sketch, but I forgot. So, have you ever wondered why India has such diverse landscapes? We have snow-covered Himalayas in the north, vast fertile plains in the middle, ancient rocky plateaus in the south, deserts in the west, and coastal plains on the both sides, coral and volcanic islands. These differences are not accidental. Remember, they are the result of millions of years of geological evolution. I've said this before. So, to understand this diversity, geologists divide India into three major geological divisions based on alright, India. Okay. Based on what? Based on geological history. Okay. Geological history, rock types. Remember, rock types, geological age, tectonic activity. Okay, tectonic activity, and landforms. Remember, so all of these are the reasons. Based on this, India divided into three major geological divisions. So this division helps us understand the origin and evolution of India's physical features. So a geological division is a region classified. So it is classified based on its origin, age, rock structure, tectonic history, and geological characteristics like. So in simple definition, we can tell it. It tells us how different parts of India were formed and how old they are. Now let us see why is India divided geologically. Although India is one country politically, it is not one geological unit. Different regions. Example, different regions formed at different times, have different rock compositions, have different tectonic histories, experience different levels of seismic activity. For example, the peninsular plateau is over 3 billion years old. The Himalayas are only about 50 million years old. So this huge age difference explains why they look and behave so differently. Now, according to NCRT, and in reality, so there are three major geological divisions in India. Okay, what are those? One is the peninsular block. The peninsular block. Okay, and the other one is the Himalayas. And other peninsular mountains and other peninsular mountains, and the third one is Indo-Gangetic plain or Indo-Ganga Brahmaputra plain. Brahmaputra plain. These are the three major three geological divisions of India. Now let us see what is peninsular block. The peninsular block. Let us discuss now. Let us try to understand what is the peninsular block means. The peninsular block is the oldest and most stable geological unit of India. All right, it is the oldest and most stable. Okay. Geological unit of India. It forms the triangular landmass south of the northern plains and is often called the geological heart of India. It is also called as geological heart of or geological heart of India. Why? Because it forms the triangular landmass south of the northern plains. Okay. Now the peninsular block is a ancient stable landmass composed mainly of it. What exactly it composes? Am I right? I'll try to adjust. Chalo. So it contains peninsular block composed mainly of igneous and metamorphic rocks okay, and they are formed during Precambrian era. Remember, Precambrian. So in simple definition, it is the oldest part of India which has remained stable for billions of years. Okay. Why it is called a stable block? Why? Because a stable block is one that has experienced very little folding or tectonic disturbance over a long period. Simple. It's that simple. So the peninsular block has remained largely unchanged for billions of years. It is far from active plate boundaries, and it experiences comparatively fewer earthquakes when you compare with other blocks. Okay. When you see Himalayas, you will see very most of earthquakes occur there. Now let us see what are the types of rock presents. What are the type of rock generally seen in peninsular region? Rock types. So the peninsular block is mainly made up of, one is igneous, another one is metamorphic. So alright, igneous rocks examples include granite. Remember, granite. And then we have basalt rock. Now the other one is second one. First one is igneous, second one is metamorphic rocks. Okay. Examples like this quartzite. Okay. And another one is schist. Okay. That's it. So these hard crystalline rocks are highly resistant to erosion. Okay. Now peninsular plateau is very rich in minerals. Over billions of years, geological processes led to the concentration of valuable minerals. And what are the major minerals here? Alright. We have seen rock types. Now major minerals in peninsular block. What are those? Iron ore. Okay. Iron ore, manganese. Okay. And we have bauxite, mica, copper, gold, coal. Okay. So this is why states like Jharkhand, Odisha, what else, Chhattisgarh, Karnataka and Telangana are mineral rich. So now let us see what are physiographic characteristics. Let us see physiographic characteristics. Now the peninsular block is characterized by rolling plateaus. Remember, rolling plateaus and rounded hills. All of these are the characteristics of the peninsular block. And residual mountains, ठीक है, rolling plateaus, rounded hills, residual mountains. What else we have? Ancient crystalline rocks, ancient crystalline rocks, ancient crystalline rocks, and broad river valleys. Yeah. So unlike the sharp, rugged Himalayas, these landforms have been worn down by erosion over millions of years. So why rivers are here very different. The rivers in the peninsular plateau are very different compared to others, because they're older, they flow through hard rocks, they have fixed courses, they create waterfalls, gorges. Okay, examples like Godavari, okay, Krishna, and Kaveri, okay, Narmada, Tapi. So yeah, although the peninsular plateau is relatively stable, this block is not completely free from earthquakes. Remember, okay? There has been examples include. I'll try to recall. There is Bhuj earthquake in 2001. That was occurred in this region. So that is what I can recall. So what is the importance of peninsular block? It is the oldest geological unit of India, a rich source of minerals we have discussed, foundation of the Indian landmass, okay, and major source of hydroelectric potential through waterfalls, and it supports extensive agriculture through river systems. Note all these points. Now let us see the second one, that is Himalayas and other peninsular plateau and other peninsular mountains. Sorry, Himalayas and other peninsular mountains. So unlike the peninsular block, this Himalayas are young, dynamic, and tectonically active. Very sorry, I have to drink some water. So unlike the peninsular block, the Himalayas are very young, dynamic, and tectonically active. So they are formed when the Indian plate collided with Eurasian plate. Remember. So what are the characteristics? What are the characteristics of this? First one is they are young fold mountains. The young fold mountains, they're still rising, okay? They're still rising, okay? And frequent earthquakes is the characteristic of the Himalaya. And deep, we are able to see deeper river valley or deep river valleys, and high peaks. We're able to see high peaks here, and glaciers, okay? And landslides are common, okay? Landslides are very common here. So all of these are characteristics of Himalaya. So yeah. So what is the importance of Himalayas? They protect India from the cold Central Asian winds. So they intercept monsoon winds causing rainfall. They feed perennial rivers through glaciers. What else? They influence India's climate. They act as a natural barrier. So yeah, that is about the Himalayas. The other one is Indo-Ganga Brahmaputra Brahmaputra plain. So so this is the third major geological division. So the northern plains were not mountains or plateaux originally, because they formed through deposition of sediments brought by rivers. So when the Himalayas rose, so so when the Himalayas rose, rivers such as Indus, Ganga, Brahmaputra eroded enormous quantities of rocks. Okay, and okay, that sediments accumulated in the foreland basin. Okay, in the foreland basin of south of Himalayas. Okay, over millions of years, these basin was filled, forming the fertile northern plains. Okay. Now, what are the characteristics? Characteristics. Let's see. What are the characteristics here? The first one is they are flat and extensive. Flat and extensive. Okay, I'm very sorry about my writing. My handwriting is not that much good, but just adjust and bear. Highly fertile. We're able to see highly fertile alluvial soils here. Okay. Dense population. We're able to see dense population. And then intensive agriculture. Okay. And rich groundwater resources. Rich groundwater. Okay. Now I'm keep on telling, it is very fertile, highly fertile. Why? Because rivers deposit fresh alluvium every year. No, and that replenishes soil nutrients. So this makes the Indo-Gangetic Plain one of the world's most productive agriculture region. Remember. Now that we have understood three geological divisions, okay? Peninsular block is the oldest, Himalayas are young, and Indo-Ganga Brahmaputra are youngest. Remember. And peninsular block, the origin is Precambrian shield, and for Himalayas it is plate collision, and for Indo-Gangetic Plain it is river deposition, sediments. And what are the types of rocks for peninsula? Igneous and metamorphic. Okay? And Himalayas sedimentary, they're folded. And Indo-Gangetic Plain, alluvium type of rocks. And most stable block is peninsular block. Okay? And Himalayas are highly active, and Indo-Gangetic Plain, they're relatively stable. So earthquakes less frequently occur in peninsular block, whereas frequently occur in Himalayas, and moderate in Indo-Gangetic Plain. So that's about the Indo-Gangetic Plain and the major three geological divisions. So remember the fact for the UPSC exam. Okay. So although we have introduced it here, the peninsular block, in the next lecture we'll study it exhaustively, including what are the Gondwana land and Gondwana rocks, Deccan traps, volcanic origin, major plateaus, Narmada Sun, and mineral belt, and drainage evolution, etc. So let's see. Let's try to cover this. Let's try to cover that topic here only. So, okay. I'll drink some water. Just wait. So now let us complete the peninsular block in a very detailed explanation. What are we have missed in first we're going to cover here. So peninsular block in a very detailed explanation. So we have seen peninsular block is the oldest and most stable geological unit of India. Okay, why it is called peninsular block? Why it is called peninsular block? Why? Reason is, remember, a peninsula is a piece of land. Peninsula is a piece of land surrounded by water surrounded by water on three sides. Water on three sides. Remember. Okay. I think most of you remember the Indian diagram, right? Okay. Here we are able to see Arabian Sea. Okay. Arabian Sea in the west. Okay. And we have in the east we have Bay of Bengal. Okay. Bay of Bengal in the east. And in the south we have Indian Ocean. Okay. A piece of land which is surrounded by water on three sides. Okay. So that is why it is called as peninsula. So we have seen the different type of rock types here. Okay. That is granite and the gneisses. You know why rocks are important. And okay. And we have also seen why is the peninsular block is stable. Okay. And there are some earthquakes occur in peninsular block also, so remember that. So there are two major divisions, remember this. Two major divisions of the peninsular block. What are those two? One is Central Highlands, that is north of the Narmada River. Okay. We are able to see Malwa Plate, Budelkhan Plate, Pagelkhan Plate, Chotanagar Plate show, everything in Central Highland. And the other one is, I'll write, if possible, I'll write here, Malwa Plate, Chotanagar Plate show, Chota Nagpur, and then we have Bundelkhand. Okay. Another one is Pagelkhan. So Central Highland and other division is Deccan Plateau. Okay, it went too very far away. Deccan Plateau. It is south. It is north of Narmada River and it is south of the Narmada River. Okay. We are able to see here, Maharashtra, Telangana Plateau, Tamil Nadu, Karnataka Plateau. The Narmada River serves as an important geological divide between Central Highland and Deccan Plateau. So yeah, we have also discussed regarding Peninsular Plateau and its minerals. Okay, and we have just seen the rivers, but we missed the detailed explanation of drainage of the peninsular block. We're going to discuss that here. Drainage of the peninsular block. So this plateau has a general slope from the west to east. Okay. So examples, what else I have already discussed: Godavari, Krishna, Kaveri, Mahanadi. Okay. And exceptions include Narmada and Tapi. These two rivers flow westward through rift valleys into Arabian Sea. So except those. Now we have seen the characteristics and the earlier regarding the rounded hills, residual mountains, waterfalls, gorges. Okay. And yeah, so this is about the peninsular block detailed explanation, and let's see what are the points we missed in the second geological division, that is the Himalayas and other peninsular mountains. Himalayas and peninsula. Okay, we have already discussed regarding this. The Himalayas are very young fold mountain system. They are found by the collision of Indian plate with the Eurasian plate, and yeah, we have already discussed about the complete story regarding formation of Himalayas. The Gondwana land, the breakup, and the rapid northward journey, collision, etc. Okay. And we also discussed why are the Himalayas called a fold, young fold mountains. What is the reason behind that? And we also discussed characteristics of the Himalayas. Okay. And there is this topic I missed, that is the three parallel Himalayan ranges. The three parallel Himalayan ranges. What are those? I'll discuss. First one is Himadri. Remember, Himadri. This is Greater Himalaya. Okay. It is also called Greater Himalaya. It is known as Himadri. So Himadri is the northernmost, highest, and most continuous Himalayas range. Okay. I'll write here. Himadri is the northernmost, highest, and most continuous Himalayan range. Okay. Himalayan range. Okay. And average height of mountains here is 6,000 meters. Remember, permanently snow covered. Okay. And contains highest peaks, and they are the major source of glaciers. Okay. And yeah, so what are the important peaks here? What are the important peak? I'll write IMP for important peaks here. First one is Mount Everest. Everybody knows this, right? Mount Everest. And the other one is Kanchenjunga, India-Nepal border. This was in Nepal, and this is India-Nepal border, highest peak in India. The other one is Nanda Devi and Comet. Okay. What is the importance? It stores vast quantities of fresh water as glaciers. Okay. And it's a origin of perennial rivers, like perennial rivers like Ganga and Yamuna. Remember, Ganga and Yamuna. So yeah, so it also acts as climatic barrier. The first one is Himadri. Okay. The second one is Himachal. Himachal means lesser Himalayas. This is Greater Himalaya. This is Lesser Himalayas. Okay. So it is located south of Himadri. Located south of the Himadri. Okay. So average height of the mountains is around 3,500 to 4,500 meters. So they're highly rugged, and they are famous for valleys and hill stations, etc. So what are the important valleys here? The first one is Kashmir Valley. Okay, Kashmir Valley. The other one is Kangru. Not Kangru, it is Kangra Valley. Sorry for the mispronunciation. Kangra, and the other one is Kullu Valley, and this is in the news remember. And we have covered important valleys. Now let us see important hill stations. Important hill stations. Just remember, nothing wrong in remember, right? We're able to see Shimla hill station, or all of these are hill stations. And another one is Mussoorie, the dream place of every one of us. Okay? And the one is Nainital and Dharmshala. I mean, Dharmshala, whatever it is. Okay? What is what exactly the advantage of this is, tourism. Okay? Tourism, apple cultivation. Okay? Dense forests are there. Okay? The third one is Shivalik. Okay? Now you remember Himadri, Himachal, Shivalik. Shivalik means outer, it also called as outer Himalayas. Okay? So it is the southernmost Himalayan range. Okay, all right. The southernmost Himalayan range. Okay. The ranges here, lowest range. Okay. And average height of mountains or peaks are 9 to 1200 meters. It's very lesser. Okay. And it formed from loose sediments brought by Himalayan rivers, and they are most prone to erosion and landslides. So what are the special features here? There is one thing. This is this Terai, marshy belt south of the Babar, that is extremely fertile and rich in forest and wildfire. And just remember this: Babar and Terai. UPSC, asked repeatedly in prelims regarding this too. Babar is, the Babar is narrow belt of coarse pebbles, and rivers disappear into the porous ground here. And the Terai, it is a marshy belt south of Babar. Okay, rivers re-emerge here, and extremely fertile and rich in forest and wildlife. So, okay. Now, what is the importance of Himalayas? One is climatic importance, other one is source of rivers. We have Indus, Ganga, Brahmaputra. Another one is biodiversity. The Himalayan contain alpine meadows, coniferous forest, temperate forest, tropical forest. Okay? And they're home to snow leopard, red panda. What else we have? Musk deer, Himalayan tar. Okay? They're economically very important because tourism, pilgrimage, hydropower, medicinal plant, forestry. Okay? And yeah. Okay? And we have other peninsular mountains also. Unlike the Himalayas, they are very old mountains. Examples like Aravalli Range, one of the oldest fold mountain in the world. Highest peak is Guru Shikhar. And the other one is Vindhya Range. Okay? Aravalli Range, Vindhya Range, Satpura Range, Western Ghats, Eastern Ghats, Nilgiri Hills, Anaimalai. I call it as a Annamalai, but it is actually Anaimalai Hills, Cardamom Hills. All of those are the old they are the old peninsular mountains so far. So remember this. Okay? So the Himalayas are more than just a mountain range. They are the backbone of India's physical and economic geography. Remember this. Okay? Now we are going to see the other topic, that is the northern plains. We can also call it as a Indo-Ganga Brahmaputra plain. Okay? We already discussed about why it is called Indo-Ganga Brahmaputra and the tributaries. Indo-Gangetic plain, or the Indo-Ganga Brahmaputra and the tributaries. Okay? The reason is, the northern plains are very extensive and low-lying alluvial plains. Okay? ठीक है, इंडो गैंगेटिक राइट प्लेन और नॉर्थन plains. Now because these are these are very vast fertile plains, okay, and that fertile plains created by rivers, okay. Generally there are types of formation generally happen here, the formation of northern plains, because we have already discussed regarding this. It's on formation of Himalayas, then erosion began, then the sediments, they are carried downward and then deposited, so gradually the basin was filled, forming today's northern plains, okay. And they are also called as alluvial. I'll already discuss this. They are called as alluvial plains, okay. Why? Because alluvium is loose material deposited by the rivers, and deposition of sediments, okay, it is carried by rivers. It includes sand, silt, clay, gravel, examples. So these are the best examples. So these sediments make the soil extremely fertile, okay. So what are the major river system here? Major river system, one is Indus river system. Remember, I like important one only rather than writing everything. Indus river system. The other one is Ganga river system. Ganga river system, okay. And Indus river system, it has major tributaries like Jhelum, Chenab, Ravi, Beas, Sutlej. And for the Ganga, there are major tributaries like Yamuna. Can I write? I'll write here so that you'll get understanding. Jhelum, Chenab, Ravi, Beas, or Beas, Sutlej. Okay, these names are quite crazy. The other one is Yamuna. This one is Gagara. And what is Gandak, Kosi, and Sun. Okay, so yeah. So Brahmaputra river. The other one is, I missed it. Brahmaputra, Indo Ganga, Brahmaputra, right? So Indo Ganga. Other one is Brahmaputra river system. Third one. This is first, second, and third. So generally, it originates in Tibet, and enters India through Arunachal Pradesh and flows through Assam before entering Bangladesh. So it forms one of the world's largest river valleys and floodplains. Remember this, okay? So I've told about Babar, right? So Babar is a narrow belt of coarse pebbles and gravel found along the foothills of Shivalik range. Remember, okay? I can just give you a UPSC tip. Babar mean, just remember this: rivers are lost in Babar due to infiltration. Okay, rivers disappear in that region. So other one is Terai. So generally rivers reappear on the surface. Okay, and Terai also one of the important factor here, that Terai supports important wildlife reserves such as Jim Corbett National Park, and we have, yeah, that's what I can recall right now. So yeah, so this is about the Indo-Gangetic plain or the northern plains, okay. And what is the importance of these plains? Agriculture importance, okay, often called as football of India, because they produce wheat, rice, sugarcane, maize, pulses, okay. And what are the economic importance? Dense transport networks are seen here, major industrial centers, large markets, high urbanization. Cities like Delhi, Kanpur, Lucknow, Patna, and Kolkata developed because of these plains, okay. And yeah, so this is about northern plains, and we have already discussed Peninsular Plateau. So yeah, so the Indo-Ganga Brahmaputra plains is both a blessing and it's a gift for India. Okay, remember that. So we have discussed about India's geological divisions, and now we are going to shift India's India's physiographic physiographic divisions. What are those? India's physiographic divisions. Okay. There are six major physiographic divisions of India. One is northern and northeastern mountains, northern plains, peninsular plateau, Indian desert, coastal plains, and island. For each division, we'll study location, formation, geology, climate, rivers, what else, biodiversity, economy, etc. Okay. So this is all about for today's lecture. See you in the next lecture. Until then, see you. Bye.